Duncan, and I'm gonna do estimating regression parameters. Alright, so at first I'm gonna introduce regression. Regression is the relationship between your independent and dependent variables. In this case, it's a positive linear regression model. The yellow line is the regression line that's supposed to best fit the data points, and your two variables are x and y. How I helped grasp this was beta naught is just like the slope intercept in slope intercept form, and beta 1 is like your slope. And an example of this in real life would be like a graph that showed the relationship between height and weight, and how usually when your height increases, your weight usually increases, which is not always the case, but most of the time it is. Least squares method is the method that's most commonly used to find your regression parameters, and that's usually denoted by the height of your points, which is di, which is like these lines on the y-axis, subtracted by the equation of a line, which is the b naught plus b naught, or b sub I times xi. These red lines, which is like the distance between the point in the line, is denoted by, or is called the residual. And yes, the residual. And this is the form of sum of the square, or the least squares method. All right. The formula for your parameters. I created this chart over here on the left, which is just random values of x and y, and the sum of x squared, y squared, and x times y, denoted by this last thing. And then there's four points that I chose, so n was equal to number of points, which is 4. This formula for your slope, or your beta 1, is equal to n sum of x times y minus the sum of x over the sum of y, and n times the sum of x squared minus the sum of x squared, and that'll give you your beta 1, which is your slope, and your y-intercept, or your beta naught, is equal to the sum of y minus your slope, which is beta 1, times the sum of x over n, which is 4. And those are my sources. Boom.